So 10, 11, 12. Okay, so on 10, how would you find this number right here? 98 divided by 14. What would that give you? Is 9? 7. Okay, and then what's 7 plus 14? 21. All right, in order to get this next one, we have 28, and we're going to divide it by -4. So what is that going to give us? All right, -7 plus -4 is? Fantastic. The next one's kind of the opposite. In order to get this guy, we're going to subtract. What's 9 minus 5? 4. And what's 4 times 5? 20. Ta-da. On the next one, we have the two sides are missing. So we need two numbers that multiply to get you 90, but add to get you 21. Multiply to get you 90, add to get you 21. Did anybody come up with that one? Is it -21? No, it's +21, right? It is? Okay, sorry, couldn't see it. So it's going to be -15 and -6. Everybody agree? Yes? Okay. What about the next one? Multiply to get you 12, add together to get you -8. Okay, Isis, how are you doing this? Like, how do you figure those numbers out? Okay, so she said, hey, what are factors of 12? And then which ones can I add together to get me -8? Okay. On the next one, what are factors of 77 that add together to get me 18? 11 and 7. Okay, so this is where that multiplication skills really come in handy. Okay, you have to know at least a few multiplication skills in order to do this. Okay, again, if you're struggling with that, you need to practice. What number is halfway between 1 and 5? So let's think 3. Okay, good. So we would have 2 here, 3 is right here, and then 4. So halfway between is going to be 3. Cool. What about the next one? -1 and 5. +2? Okay, so that would give me 0, 1, 2, 3, 4. Okay, notice how there's 2 blue numbers on each side. And then what about -1 and 4? 1. Okay, so that would give me 0, 1, 2, 3. That's not right. Okay, that would give me 0, 1, 2, 3. Same problem. So what's halfway between 1 and 2? 1.5. So everybody see how I did that? Looking at that next part, it says this graph shows the amount of water left in a jug after filling up different number of cups. Okay, so on the initial, we have 128. How much did it go down by from here to here? Go down 18? How much? It went down by 8, right? What about the next one, 120 to 112? 8, right? So what would be the next one? It would go down by 8. So what's 112 minus 8? 104, close. All right, subtract 8 from that. 96. Subtract 8 from that. Now we're going to plot these points. I know that when we plot, ooh, nobody called me on this. I'm sorry. Go back. Notice how we went from 3 to 10. So how would we go about finding that? So -8, 10 more times, right? So what would that be? Say again. 56, y'all agree? Y'all are agreeing because y'all didn't do the math. 40. What you saying? No, what? You're saying this is 56? Oh, okay. Why 56? 8 times 7 is 56, so that's how much we would subtract, right? Okay, so what's 104 minus 56? 48. There we go. Cool. Now we're going to plot these. So we've got 0, 128, 1, 120, 2, 112, 3, we got 104. It's like right in there. 4 probably is like right in there, but we didn't actually do anything here. What about 10, 48? So we're going to go 10 and then 48. Give me like right here. So if we connected this, what kind of function is this guy? Linear. Okay, so how do we write the equation out for this? We say that it's linear. So we remember that linear equations are y equals mx plus b, right? What's our slope? What are we going down by each time? -8. So we got y equals -8x. What was our initial amount? 128. Duh. Let's explore a new type of relationship. Here's a visual pattern. I want you to try to sketch the pattern for figure 4. Okay, so really quick, how many did we start with in figure 1? 2. Okay. And then how many do we have in figure 2? 6. Yep, 6. Okay, and look at how they wrote it. They said 2 to the second power plus 2. What does that mean? 4 plus 2, but why'd they write it like that? Go ahead.
It's like 3 times 2 equals 4 and plus 3 equals 6. There's 6.
Okay. So how many are there on 3? There's 12. Okay. So there's 12. And how did they write it? They wrote 3 squared plus how many? 3. Can you sketch number 4? Is there a different way we could have written figure 1? Could we have written it like this? 1 squared plus 1? That gives me 2, right? Okay, do you notice a pattern? What's happening? Sean?
4. We're doing 4 squared plus 4. Because for each figure there's like several big squared twice and then it's added by several.
Okay, so what would 10 be? Fantastic. Okay, so let's sketch that pattern. Okay, so that's going to be, and I apologize for my not straight lines. If I had this, I'd have that, and then plus 4, right? On just like the outside. So 1, 2, 3, 4. Look at that awesome photo. Yes. So how would we go about writing this within? So in terms of in. So instead of a number, we're going to put in. Okay. So that's going to give me n squared plus n. That's our pattern, right? And the number of tiles is called a quadratic because the number is squared. So we took 1 and squared it, 2 and squared it, 3 and squared it. That makes that a quadratic. So that 2 is the exponent makes it a quadratic. So what are some things we want to remember from this? Anything specific that sticks out to you? Things we want to remember from that. Yep.
It's only like all squared about whatever figure it is, and then you add it back when you.
Okay, so squared equals quadratic. Okay, and we won't always have like it's added by itself. That won't always be the case, but we'll definitely have something along the lines of n squared. Okay. Let's kind of think through this pattern. So what's going on from figure 1 to figure 2? We see that there's a box and we got these 3 on the outside. And then we see that we got a box and then we got 3 on the outside, right? And then we see we got a box and we got 3 on the outside. But those numbers are increasing, right? Okay, we've got this square. A square is always going to be equal in width and length. So this is like a 1 by 1. This is a 2 by 2. This is a 3 by 3. So what we're doing here is we're taking the number, squaring it, and then adding 3 to it. Here we're taking 2, squaring it, and adding 3 to it. Here we're taking 3, squaring it, and adding 3 to it. So what would figure 10 look like? Okay, so 10 squared would be 100 boxes, right? 110. Because if we're taking 3 by 3, that's 9, right? And a 10 by 10 is what? 100. Plus you got those 3 little boxes on the outside. Look at my awesome thing. So this would be 100 tiles, also known as a 10 by 10, and then add 3 tiles. Now this next question always pops up and it's kind of like weird. So it says, how many tiles would figure n have? Remember, this is just writing out the formula. So we would have n squared plus 3. Because each time we would take the number, square it, and then add 3 to it. Now, is this relationship quadratic? Is this relationship quadratic? Is the number squared each time? Yes. The figure number is squared. Can you try the next one? Just talk me through this really quick. What's going on? Okay. So we're starting off with 5. We're adding the 2 up at the top. And then we have 2 rows of 5, and then adding 2 at the top. And then we have 3 rows of 5, and then we're adding 2 at the top. Do you ever? All right, so how would figure 10 look? How many rows of 5 are we going to have? Okay, so we would have 10 rows of 5 plus 2 at the top, right? So that would be 50 tiles plus 2, which would be 52, right? Now, how many tiles would figure n have? So how would we figure that out? Well, we would have n times 5, because each row is 5, right? And then we would add 2 to the end. Does everybody see how I did that? So I have 5 in a row, and each row represents n. Now, is this a quadratic? Why? It's not squared. So no, it's not squared. Look at y'all, crushing the game, killing. So on this first one, select all the expressions that can represent the area of this figure. Which one did you pick? A, B, C, D, or E? B. Okay, so talk me through this logic. Y'all said B, D, E for the most part. Somebody said C. Huh? Okay, so how many tiles are there in total?
29.
3, 4, 5, 6, 7, 21 plus 4 plus 4. Yeah, 29. Okay, so there's 29 in total. So if I multiply this out. Let's see if I can get 29. 5 times 7 is 35. 35 minus 6, that's 29. So that one works. Okay, on the next one, 3 times 7 is 21. 2 times 2 is 4. 21 plus 4, is that 29? Okay, so not C, not A. On the next one, 35 minus 6, is that 29? Yes. And then 2 times 5 is 10, plus 3 times 3 is 9, plus 10, is that 29? Yes. Okay, so it's either B, C, B, C, or E, right? But let's look at it. This is a 3 by 7, right? And then we have two 2 by 2s. Okay, so we have a 3 by 7. I'm sorry, we have a 5 by 7. Is that what this says? No. Yeah, 5 by 7. And then we subtracted 6. Why did they do 5 by 7? 5 by 7. Because this is what? 5 rows long? And then why did they subtract 6? Because that missing piece, right? Oh, definitely this guy, right? This guy's right. I should probably mark this correctly. There we go. So this guy is right. Okay, let's look at this. They said 5 by 7, and then they said minus a 2 by 3. Does that make sense? A 2 by 3? Yep. That one works too. What about this last one? We have 2 by 5. And then we have a 3 by 3. And then we have a 2 by 5. So we have a 2 by 5. And then we have a 3 by 3. And then we have a 2 by 5. Did we see that? Okay, cool. So all 3 of those work. Yeah. There's always like a question on your final or on your EOC that literally does this. It's like select all that makes sense for this process. Okay. Let's go ahead and look at the next one. Draw the pattern for S equals 4. Okay, so what's going on here? What are we doing? Well, we got one row right here, and then we got a 2 by 2 and a 2 by 2. And then we have 2 rows, and we got a 2 by 2 and a 2 by 2. And then we have 3 rows, and then we got a 2 by 2 and a 2 by 2. So what's going to be the pattern? 4 rows. And how many tiles are sideways? 1, 2, 3, 6, 7. 7. So we have 7 with 4 rows. 1, 2, 3, 4, 5, 6, 2, 4, 6, 7. And then we got that 4 by 4. Look at that awesome box. So good. Okay, how many tiles are in figure 10 in the next one? Well, how many are figure 2? I'm sorry, how many are figure 1, 2? How many are in figure 2? How many are in figure 3? 4, 8, 12, right? So what's going to be in figure 10? Yeah. It gets wider. So we add a row and then we add one this way. Okay, so how do we really say that? The first one?
Yeah. Oh, yeah, so they add another one for like each.
Oh, you're right. You're right. So we should have another column. My bad. I apologize. Yeah. Boom. Better. So we have 8 going this way, and then we got 4 rows with the 2 thingies. Cool. Good catch. All right, so on this one, we got 2, 6, and 12. So what's happening here? Multiplying by 3? Are you sure? What if we look at it this way? We have a 2 by 1, and then we have a 2 by 2, and then we have a 3 by 3, And look at how we're adding an extra file each time, right?
Mhm.
So what if we said x squared
Plus.
plus x, because whatever the figure number is, that's what we're adding on each time, right? So if I was doing 10, then I would plug in 10 squared and add 10. So what's 10 squared? Plus 10. Ta-da. Did y'all get to number 4? All right. What type of relationship does a pattern in the table represent? So each time, what's happening?
Just multiply by 3.
It's multiplying by 3 each time. So is that linear?
Yes.
Remember, linear, we're going to add something each time or subtract something each time. Is it squaring each time? No. So this is going to be called exponential because we're multiplying by 3 each time. If it was a quadratic, we would find like the first difference and then we would find the second difference, and the second difference would be the same. Okay, go and flip over. Did y'all get to number 5? Okay, I'll give you a couple minutes. So go ahead and try. Okay, go ahead. So it could be either multiplying by 5 or adding 20. So it could be exponential or it could be linear, right? Good. Okay. How many tiles would be in the next step if it were linear? So if it were linear, how many would there be? 45, right? Because we're adding 20, right? What about exponential? Because 25 times 5 is 125. Because multiplying by 5. This person's name. Is it Juana? Began hiking at 6 a.m. At noon, she hiked 12 miles. At 4, she finished her hike with a total of 26 miles. This chick's hiking the marathon. On average, during which time interval was Joanna hiking faster? Circle 1. Okay, so from 6 a.m. to noon, she had hiked 12 miles. And then at 4, she finished her hike with 26 in total. So from 6 to noon, how many miles did she hike? 12. And then from noon to 4, how many did she hike?
14.
14. How do we get that? How do we get that? We took, right. So 26 minus 12 gave me that 14. So she hiked faster from noon to 4 because she was hiking more in a short amount of time. Does that make sense? In 12 hours, I'm sorry, in 6 hours, she hiked 12. In 4 hours, she hiked 14. But she was booking it in that last bit. She was like, I gotta get this done. Have y'all ever ran a marathon before? Walked a marathon? Walked a half marathon? Nobody. Anybody done a 5K? They give you like a little medal. I don't know. I did a marathon in Helen, like back in April, May, and it was like up a mountain for 15 miles. It was horrible. It was the worst experience I think I've ever been through. Like, and I have played every sport known to man, but like the hike up that mountain, like, I'm not talking just like walking up a mountain. Like, this is rocky, unstable, and it was raining. So like it was just a horrible experience. Never doing it again.